Welcome back to Aarambh Dev. I am your host, and today we are diving into a very exciting topic. Latest stable release of our favorite language, Rust 1.89.0. The Rust team is constantly pushing the boundary of performance, safety, and ergonomics. And this release packed with some fantastic improvement that will make your life as a developer easier and your code even more powerful. Before we jump in, if you are fascinated about the Rust and software development, make sure to hit the subscribe button and ring the notification bell so you don't miss any of our deep dive. And if you are find value in this content, consider support the channel on Buy Me a Coffee or join our awesome community on Discord. The links are in the description below. Your support helps us to create more content just like this. Alright, let's explore what the new in Rust 1.89.0. The biggest and most impactful feature in this release, without a doubt, is the expansion of our what can do at the compile time with Const function. For those who might be a new to this, Const function is in Rust R function whose result can be computed as a compile time. This is incredible power. It means, it means you can perform complex calculation, generate lookup table, or set up a data structure before your program even runs. The result is backed directly into your binary, leading to zero runtime cost for the computation. Before Rust 1.89.0, the const functions were quietly limited. You could not be used control flow like if statement, match expression, or loops. This made writing any non-trivial logic very difficult, often forcing developer to use complex macro instead. But now, that all has changed. With 1.89.0, you can now use if, match, and loop directly inside your const function. Let's see what it actually looks like and why it is a game changer. Let's create a practical, non-trivial example. Imagine we want to create a compile time lookup table for Fibonacci number. Previously, this would have been a very chunk. Now it's clear and distributed. Let's write a const function to calculate the end Fibonacci number. Look at this code. It's just a normal readable Rust. We have if statement of our basic case. We have loop to perform iteration. The beautiful part, all the logic is executed by the compile time. When we are run our program, the value of 55 and 6765 are already computed and stored in FIB10 and FIB20 constant. There are no function call at a runtime, no loop, nothing is incredible effection. Let's take a step further. What about the match? We will write the const function that give us a description for the HTTP status code. Again, this is Hub. You can now build compile time state machines, parse and validate using automatic Rust control flow. This dramatically lower the barriers of the writing powerful const code and widely likely reduce the community relation on the complex modular macros. For this kind of tasks, It's a massive win for writing cleaner and more maintainable and highly performance code. From making our code faster at the runtime, let's talk about the future that make our code safer during development. Our next feature is all about preventing a very common and suitable bug in asynchronous programming. You probably familiar with the hashtag underscore hashtag must underscore use. Like I am showing in the screen, you can see here must underscore use. This is attribute. You see it only types like a result. If a function return a result and you do not do anything with it, you don't match it, unwrap it, or use the question mark operator, the compiler give you a warning. This is circular because it stops you from accidentally ignoring potential error. Now, this same potential has been extended to the asynchronous function. Theoretically, to understanding this, so when you view call async function, it does not actually run the code inside it instant. It run a future. A future is like a recipe for a computation. Recipe for a computation is a blueprint that say here what need to be done. To actually execute that recipe, you need to asynchronize runtime, like a Tokyo or async STD to pull it. That's what the .await keyword does. It hand the future hour had been runtime and say, please run this and give me the result when it's done. A very common mistake especially for beginner is call an async function and forget to await it. Let's see what happened before 1.89.0 and what happened now. Imagine we are writing an asynchronous function that simulates saving the data to a database. In older version of Rust, this code would not compile without any warning. Your program would be run, print, calling async function and main function finisher, and then exists. The save function, the save data function would never actually executed its logic because its future was never pulled. Your data would be silently loose. This is a trivial bug. But now in Rust 1.89.0, the compiler is your safety net. If you are compile the same code, you will get the helpful warning. This is fantastic. The compiler accidentally tell you what you have created to future that need to be used, likely by awaiting it. The single change will be preventing continuously sustaining bug in a synchronized Rust application. It makes the language safer and easier to get right, which is always be a core instant tenet of Rust. Now we are covered the biggest performance and safety update. Let's look at some of the smaller but still very welcome APIs. Improvement that around out this release. Every Rust release comes with a host of a smaller API stabilization. There are a function and thread that have been tested in the native version and are now ready for everyone to use in stable Rust. First, in the word of FFI or forensic function interface, we have CSTR string is empty. When we are working with C style null terminator string, you often don't need to know if a string is empty. Previously, you might be have to convert it into byte slice and check it length. Now there is simple direct matter of it. It's a small thing, but it improves clarity. What if you are writing unsafe code to interfacing with C library? Another useful additional is a core FFI. I will show you here. Wait a minute, I am writing core FFI from F capital from bytes until null error. When you create a SS string from a byte slice, it will can be fed in a two-way. Either there are no null terminator or there are the null terminator in the middle of the slice. This new error type let you the discussion between the dash two case, which can be you very helpful for debugging FFI issues. Finally, there are the more Const related API that have been stabilized, building on the theme of our first section. For example, manual drop now implement const drop and box implement const happen once. There are more advanced features, but they are feature empowering library another to build powerful compiler abstraction. There might be not be highlighted headline feature, but they are break the build of more robust and complete standard libraries, smoothing out the rough edge of development. So let's recap highlight of Rust 1.89.0. First and the most significant, we got a massive upgrade to const evolution, allowing if, match, and loop in the const function. This opened the door for writing incredible, powerful, and effective compile time logic in clean and idiomatic Rust. Second, the compiler now help us to write safer asynchronous code by warning us when we forget to dot await a future, preventing the whole class of silence data losing bug. And finally, we saw the collection of smaller API stabilization that continue to polish the standard libraries, make it more complete and easier to work with. Rust continuously is studying the match forward, focusing on performance, developer experience, and more importantly, correctness. If it awaiting exciting to see how the new feature will be used by the community to build even more amazing software. What are the most exciting about in this release? In their future you can't wait to use in your own project? Let me know in the comment below. I read every single one and love hearing from you. Thanks for watching. If you found this video helpful, make sure hit the like and subscribe and tap the notification bell so you never miss a new video. Sharing this video with a friend who learned Rust is always a hug helpful to the channel. If you want to connect with our community, you can join our on discussion. And if you like to directly support the creation of more videos like this, please consider the check out the Buy Me a Coffee page. Until next time, keep coding, keep building, and happy coding.